Hello guys, welcome to my YouTube channel Agent Pharmacy. Yes, today let's discuss on complexometric titration. See, don't worry. Later on, I will tell you what is this complexometric titration. First, you understand here complexometric titration. They are having four types: direct, back, replacement, and alkalinity. Getting na? Yes. Now see, complexometric titration simple. What is this means? Here it is a titration in which one metal and one EDTA both are reacted in the presence of a buffer. There is a formation of complex. Simple. This is known as a complexometric titration. Formation of the complex with the help of the EDTA and metal ion is called complexometric titration. Okay, simple. And mainly this complexometric titration, it helps to determine the quantity of the product, quantity of the metal, what quantity the metal is present, how much quantity the metal is present. Okay, you are going to much clarify here where in the next example. See, Ag, that is silver. What is this? Silver, it is one metal, and 2 cyanide, 2CN, it is a ligand, formation of complex. Metal ligand complex. Are you observing? No, metal ligand complex. And this metal and ligand, this complex is held by one bond. That bond is called as coordinate bond. Which bond? Coordinate bond. Clear? Now our types of titration are, first one is direct titration. In the name itself it is indicating direct means here just we are titrating directly. And metal ion made to react with the standard EDTA. Okay, standard EDTA in the presence of buffer, there is a formation of complex. Simple. Here no more complication. Directly we are taking metal ion EDTA in the presence of buffer, complex is formed. This one is direct. Now next is of a back titration. Back titration, understand this very clearly. Metal plus EDTA. Okay, we will form complex. But here EDTA you have to take in excess amount. Okay, now for an example, you have took 2 gram of metal, 3 gram of EDTA, means excess I have told you. 2 gram of metal which reacts with the 2 gram of EDTA. 1 gram of EDTA is remaining because you have took the 3 gram EDTA, no? That 1 gram, no, it again reacts with the, come to next point here, it again reacts with the zinc, and there will be formation of the zinc EDTA and liberation of 2H plus. How can you understand that there is a formation of the zinc EDTA with the appearance of wine red color? One point important here is back titration means 2-time titration. First you are titrating with excess amount of the EDTA with metal ion. Okay, that remained excess amount of EDTA again titrated with the zinc, formation of wine red color. Next is of the replacement titration. See, if direct and back titration are failed, then this method is of a choice to determine the end point. And by displacing the magnesium or zinc ions from EDTA complex with equal amount of metal ion. Okay, you are going to clarify on the next upcoming slide. See here, just what we are displacing means magnesium and zinc ions are displaced from EDTA. See, simple. See, when calcium made to react with the magnesium EDTA, there is a formation of calcium EDTA. Simple. I have told you, magnesium or zinc ion are replaced by another metal ion. Here magnesium EDTA is replaced by the calcium EDTA. So there is a formation of calcium EDTA plus magnesium. Mg, that Mg come in the box, this one blinking. What's blinking? No, you observe there. When magnesium made to react with that EDTA, there is a formation of magnesium EDTA. So that we can easily separate the magnesium EDTA, no? Yeah. See here, cadmium, lead and mercury can be determined. Cadmium, lead, mercury can be determined. Our last titration type is that is alkalimetric titration. Here very simple titration. Here also same, metal ion made to react with the EDTA, formation of the metal EDTA complex with the liberation of H plus ion. Same like direct titration. Here one important point you have to remember. Okay, what yellow color H plus you are observing, no? That H plus in unbuffered state, it reacted with the standard alkali in the presence of indicator to determine the endpoint. Only simple thing. Same as that of the direct titration, but here only H plus, liberated H plus, that is in unbuffered state react with the standard alkali in the presence of indicator, endpoint is formed. Simple one. Okay, if you understand these simple complexometric titration and types, So then thank you. Subscribe our channel Exam Pharmacy, and don't forget to turn on your bell icon notification, and please share with your pharmacy friends. Thank you.